Hi, I'm Milton Lowe,
I'm Drew Proctor.
and me and Drew decided to do the well house construction project at the Abraham Baldwin Agricultural College School Forest. Our stakeholder for this project is Mr. Grant Rents.
So the objectives of this project were number one, to build a structure over the well to protect it from the weather, as well as other components of the well, such as the gauges, valves, a spigot that's on the backside of it, and it would also help protect the PVC pipes and some other little plastic or rubber fittings that may be dry rotted, keep them out of the sun. Another objective was to enhance the appearance of the well, with it being at the main entrance and beside the main office and laboratory. The majority of the public, students, administrators, donors, anybody coming and going from the school forest normally comes through the front gate there, and it's right there in plain sight. The well house will also be used in the future by our stakeholder, Mr. Grant Rents, for storage. Anything that he may be able to prop up in the corner, you know, lay on the ground beside it, stack up with a little bit of the extra room that'll be on the inside of the well house. He can do that.
So for the initial planning of this project, me and Drew drew up 10 questions that we had from Mr. Rents about the well house and any other additives that we might need to be thinking about before we met with him. I contacted Mr. Rents through text message, and we decided it would be best to come to the school forest and take a look at the well, get all the measurements we need to decide the materials, and discuss a design for the structure of the well house. The material sheet here on we added is for what we use to price out all of our materials. As you can see, we needed 4x4 10-foot posts. We needed 5 of these, one for each corner of the well house and one for the door. We needed 3 bags of Quickcrete, uh, about a bag or so, a little less than a bag per hole that we dug. The door latches, door hinges, and we needed 1x4 10-foot stringers for the roof, along with silver tin and roofing screws. The 10-foot decking boards, we needed 80 of these to complete the siding of the well house. Each side of the well, we calculated we needed 80 boards. We needed 15 10-foot 2x4s also for the roof. And we also calculated the total after the sales tax for Mr. Rents to take a look at for any monthly spendings that he needs to write down or calculate or anything like that. We also discussed when we would meet to go get the material. We met Mr. Rents at the Lowe's in Tifton, Georgia to pick up these materials. Then after that, we unloaded the materials at the school forest and discussed with Mr. Rents the different types of tools we would need, and he told us that every tool that we needed would be provided for us, like tape measures, squares, levels, post hole diggers, hammers, shovels, power tools such as drills, skill saw, and reciprocating saw. And like I said, Mr. Rents had all of these materials on site for us to use whenever we needed them, along with ladders and other tools that we needed for the roof and any component of the well. Mr. Rents had every tool that we needed on site.
So the first process in getting this structure built was to plant the posts. In order to get our posts square and get everything equal with the two buildings around it, which was another thing, of course, with the aesthetic objectives of this, we wanted to make sure that it would match the two buildings that it would be beside. So in order to get them square, we took 4 of the decking boards we had and made our 9-foot by 9-foot square. And then we began to dig the holes for the post. Accounting for the slope that we would need in the roof, the front 2 posts are about 7.5 foot out of the ground, and the back 2 posts were about 7 foot. We came to those measurements after realizing that the well tank is 6 foot tall, And after speaking with Mr. Grant, we talked about it and we figured we'd want about a foot at the minimum at the lowest point of the roof above the top of the tank, just in case it ever had to be taken out of there or anything like that. It would be adequate room there to do that. Once we got the post holes dug and got our posts in there at the right height and all, we then leveled them up and set them with concrete. The concrete is in there just to make the posts more sturdy and durable for years to come, being that they will be the main supports of the structure itself.
So after we dug the holes, we waited about a week or so, and like Drew said, the concrete is for the stability around the base of each one of the posts. We added water to the concrete to make it harden up so the stability would last longer. We waited about a week for this so it would be sturdy enough for us to start putting up the sides. We put it after setting the corner post. We decided we needed to have some sort of board in the middle so we could have something to screw our siding boards to. As you can see in the picture here, we had 3 decking boards running horizontal to hold each 4x4 corner post together. We ran a tape from the bottom of the 4x4 post to the top and decided a measurement in the middle so it would be aesthetically it would look good to Mr. Rance. These boards were also there for stability. After that, my partner and I, we took the boards that were going to be on the outside and pushed them flush with each other, and we used decking screws to screw each one of the boards down to. We used 2 screws per board just for long term, long lasting. To complete the side, we took and put all of the decking boards, like I said, we put them flush, and we did that for all 4 of the sides.
So after getting the first wall up on the next trip out there, the next task at hand was going to be to finish up the other 3 sides and get the door completed as well. So after we came all the way around with the other 3 sides, cutting off the excess length of the boards on the top and all, we got to the front left corner where we decided our door was going to be, being that everything as far as electrical components, the valves, gauges, all that is right there on the left side of the well. So once we figured out we were going to put it in the front corner there, we then got some measurements and decided it would be about 36 inches wide and be 7 foot tall, roughly to the top of the roof itself. So after getting our measurements and the size that we would like our door, we then went and spoke to Mr. Rentz about how he would like it designed. And he then took us to show us the door on the equipment shed next door and for reference. And we roughly built it the same way, just to a smaller size, framed it up the same, and used the same design. After getting it framed up and built, we used the 2 cross boards on the picture on the left that you can see, and we used a board on the top and the bottom. That was going to help with the stability of holding the door in place, keeping all the decking boards there, and making it good and sturdy and durable for all the times it'll be open and shut here in the coming years. After getting the door and making sure it was going to fit flush and everything was correct with it, we then attached it by 2 hinges, one at the top, one in the bottom, and we used a heavy duty latch to put on the bottom and make sure that it shut. So we cut a few boards off the bottom and made sure that it wasn't interfering with the ground and would swing all the way open. Again, we made sure that it would shut flush and it would look kind of nice and neat, wouldn't nothing be sticking out or anything like that. And again, we got it to our liking, so we moved on to the next part.
Next, we started installing the roofing boards in the tin roof. Drew and I, about a week in advance of adding the tin roof on, we went and added the 10-foot 2x4s. These boards are spaced 16 inches apart, along with the 1x4 stringer boards. We spoke with Mr. Rentz about the 2x4, the 10-foot 2x4s being too long for the building, being that the building is only 9 foot long itself. Mr. Rance explained to us that it is okay to have overhang. It's for better protection for the well. The 2x4 boards are screwed to the top of each side, and the 2x4s are meant more for stability than they are for anything else. The 1x4 boards are screwed horizontally to the 2x4s, and this is for me and Drew to screw the tin to the top of the roof. After nailing and screwing the 1x4 boards to the 2x4 boards, we then screwed the tin roof down. We spoke with Mr. Rance about overlapping each piece of tin, so therefore we wouldn't have to do any cutting or any wasting of material or anything like that. So we overlapped each one and we screwed down the tin every other 2x4 board. This is to help it from blowing up if any storm events or wind or anything like that.
So looking at it, future's perspective, some improvements that can be done. One of the things that can be done that will help improve the aesthetic appearance, which will, again, was one of the more important objectives of this that we were trying to get done. We could go around the sides and plant flower beds around the outside walls. Another thing that could be done is add shelves on the inside for more storage. Kind of stack up some smaller things onto there along with whatever else he may want to store in there. Rock could also be added on the ground inside of the well house instead of having a dirt floor in case some moisture comes up through the dirt, anything else like that if you were in there trying to work on it. And lastly, another thing that will have to be done several years down the road is on the roofing screws, there's a little rubber gasket that goes between the head of the screw and the tin itself, and that is there to help make a nice sealed fit once you screw the hole in there and keep all the rainwater and moisture out. And those normally last 8 to 10 years, so again, it'll be several years before they need to be replaced.
So here's a picture of our finished product. We spoke to Mr. Rance about the appearance and he was very pleased. We met his objectives of what he would like it to look like from the road. This is the reason the picture's taken from the view of what the public would see from the road or from if they were pulling into the main office of the school forest. My partner and I also discovered that the maneuverability on the inside of the well is very good for anybody that's got to do maintenance or work on the well at any point in time in the future. They have plenty of maneuverability. The structure of this well house was to help protect the components of the well and also protect the well from future storm events like rain, hail, tornadoes, hurricanes, anything like that.
So if you have any questions or concerns, you can contact us at our emails below. Thank you for your time.